Hello, my name is Garrett Hinton, and this is Physics Lab 2, Motion of a Falling Object for Physics 2111. Uh, Brief table of contents. We start with introduction, then we go into assumptions, then we have tracker, computations, comparison, error, and what if. Introduction. The purpose of this lab is to observe the effect of drag on a falling object, and a little bit of procedure, if you will. Drop an object, track the motion in Tracker, simulate the fall in GrowScript, then simulate the fall with drag component in GlowScript, and then compare and discuss the results. Here are some assumptions and principles. In the experiment, the system is the plate that I use to drop and then track, and the surroundings are the air, which produces drag against the plate, the earth for gravity, my hand, which I released the plate from. And then we have Newton's second law, momentum principle, position formula, as well as a drag component over here, uh, Fd equals b times v squared. And then here is the tracker model with you can see some tracked points as well as some data over here, and then the graph. Here is my GlowScript components. I made two computational models, one with a drag component and one without a drag component. This here is the script with the drag component. The only difference between this script and the script without a drag component is that I adjusted the b value, which is the drag coefficient, in the script with a drag component to be 0.06 instead of 0 to model the drag. And these charts show basically they track the velocity of the object over the course of time, with the gray being the actual fall of the object, the orange being the simulated with no drag, and then blue being simulated with drag. The gray is a bit more chaotic due to maybe some discrepancies in how I actually tracked it, but the blue with the drag is relatively accurate as it follows approximately the line around the center here, and then the orange, which simulated no drag at all, is a little bit off. But what does that mean? The object was falling with a turbulent drag. The object briefly experiences terminal velocity in the model with the tracker at approximately negative 0.2 meters per second. And then as for error, the object had difficulty modeling drag as it was a relatively large object, large paper plate, and it was fairly light, only at a mass of about 0.08 kilograms, or about 8.4 grams. Difficulty in precisely tracking the object's descent due to just human error in the tracker program, and then discrepancy is the path of the object as it hit the ground and rapidly decelerated after it reached terminal velocity, and then that kind of threw off the track of the graph. And then some what ifs. What if the object was thrown? So it would theoretically have reached terminal velocity faster if the object was thrown down, but then it might decelerate based on the drag pushing against it, and then holding it at that terminal velocity. Yeah, thanks for watching.